item, which is factorial notation. Here's the factorial notation. 3 factorial means 3 times 2 times 1. Let's say 11 factorial equals 11 times 10 times 9 times 8 times ... I don't want to list all of them, times 3 times 2 times 1. So in general, n factorial will equal n multiplied by perfect times ... That's it. Okay, let's simplify a few expressions. Let's say 26. In 26, we have 20 factorial, and I will show how to do this with a graphing calculator as well. So we have 20 factorial over 2 factorial times 18 factorial. Okay. What will this be? Well, 20 times 19 times 18 times blah, blah, blah. What will be this? 18 times 17 times 16, blah, blah, blah. Okay, which of these two is bigger? Because I don't have any problem with this. This is 2 times 1, which is 2. So the bigger of these two is 20. So here's what I'm going to do, and you'll tell me why I'm doing it. Because I don't know what I'm doing. Of course I do. How come that I did not write the whole thing? 20 times 19 times 18 times 17 times 16 times ... Exactly. I stopped exactly where the smaller one was. Because these are the same quantities. When I divide, I get 1. And I will also divide. And the final answer is? Let's do this with the graphing calculator. I'm losing my voice. Okay, so we want to put in 20 factorial. 20. Let's go to math, M-A-T-H, math. Scroll across to probability with the right arrow and choose item 4. And press, I'm sorry, I didn't mean that. I meant to choose 4 first. Okay. No, I didn't mean to equal. So do not press the equal symbol. Okay, divided by, in parentheses, 2. Let's put factorial, although it's 2, but that's okay. Go to probabilities and choose number 4. And multiply by 18. Go back to math. Go to probabilities. Choose 4. Close the parenthesis. Oh no, what did I do now?
You closed it too early.
Anyway, so how much is it?
100.
How much did you get? Did we get 190?
Just error. I think it's because the parentheses was closed too early.
Yes. Okay. So we have 20 math with probability, and we choose 4, and then we divide in parentheses by 2 math, which is probability, and 4, and then multiply by 18 math, which is probability, and 4, close the parentheses.
There you go. Thank you.
Thank you.
Okay.
Okay, I checked. Good. Go back. Now, this is nice. However, in the graphing calculator, you will not be able to put in this one. Let's say 27. N plus 2 factorial over n factorial. So you won't be able to put this in the graphing calculator. What do I do now? How do I simplify this? Which of these two is the bigger? Correct. So let's see how we write this. N plus 2 times I cannot go up. N plus 1 times not just n. I have to go down to 1. Whatever I start with, I has to go all the way to 1. So this is n plus 2 times n plus 1 times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5 times n minus till 1. But I don't want to do that. Look at the denominator. Exactly. Exactly. So then when I multiply these two, I get n squared plus 3n plus 2. Exactly. So one more time, n plus 2 factorial is n plus 2 times n plus 1 times n minus 1 times n minus 2 times n minus 3 times dot 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 3 times 2 times 1. I don't want to do that because I realize that this is the bigger of the two, and I stopped so that I can simplify them. Better? Yes? Okay, finally, we can talk about the summation notation. So here's an example. 2 plus 2 squared plus 2 cubed plus 2 to the 4th plus dot 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 plus 2 to the nth power. We have a different notation for this because we don't want to list all these terms. And the notation has to have, because it's a sum of terms, the notation has to have the letter S. However, this letter S does not really work for what we're trying to do. Instead, we're going to use what it's called the Greek letter S. And this is the sigma notation. This is a much better drawing or letter than this one. So we're going to write the sum or the sigma. There must be an index. The index is either I or J or K in general. It can be other letters, of course. Let's use I. From I equals a number, and this will be the lower limit. We have not written it yet. Lower limit. And what do you think I'm going to have here at the top? The upper limit. So, and obviously, this representation has to give us that. Okay. So, what do you think I starts? What changes? Not the base.
Test message. This is a test of the Aqua Emergency Notification System.
Okay, so from I equals, so 2, the base does not change. But what changes? What is the power here? And here? And here? So what is the lower limit? What is the upper limit? Very good. From I equals 1 through n. Now, I have to write here something that when I is 1, I get this. When I is 2, I get this. When I is 3, I get this. And when I is n, I get this. So what do I write here? Very good. Very good. So, when I is 1, I have 2. The sum says add. When I is 2, I have this. The sum says add. When I is 3, I get to do the third. The sum says add. Dot, 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 till the last one when I is n, and I get to do the n. Ready for the next example? Okay, what about 51? And we have 4 plus 4 squared over 2 plus 4 to the 3rd over 3 plus dot, dot, dot plus 4 raised to power n divided by n. We don't want this long thing. We just want to write a sum that expresses the whole thing at once. What do you want to use it as the index? I, j, k, I. Perfect. I equals from 1 till, very good, from
2 divided.
You could write it as 2 to 2i, but there is no need. But you're correct. 4 raised to I divided by I. So let's check. When I is 1, I have 4. When I is 2, plus. When I is 2, I have this. When I is 3, plus, I have this. Plus, when I is n, 4 to the n over n. Agreed? Okay, perfect. So one final exercise, I promise. 33. There is nothing else. The sum from k equals 1 through 5. How many terms are there? 1, 2, 3, 4, 5 terms. From k times k plus 4. Find the indicated sum. Find the indicated sum. Ready? So please give me those 5 terms that we will eventually add. When k is 1, 1 times 5 plus, for everyone to see. When k is 2, very good, plus. When k is 3,
3 times 7.
very good, plus. When k is 4, 4 times 8, plus. When k is 5, 5 times 9, indeed. So this is 5, and this is 12, and this is 21, and this is 32, and this is 45. So what do I have? So this is 33, and 32, that's 65, and 45 is 110, 115. Okay, let's look at another example like this, in which we are asked to calculate the sum. Okay, let's look at 42. Of course, we can get fancy. 42 is fancy. I equals 1 through 5 from I plus 2 factorial over I factorial. How many terms will you give? 5. Very good. So can you simplify that inside so you can make your life easier? Let's just work on this for a moment. So if I have I plus 2 factorial over I factorial, I plus 2 times, and I stop. So basically all this is nothing else but the sum from I equals 1 through 5 from I plus 2 times I plus 1. Because I know how to simplify and I don't need that. So please give me 5 terms. First term, when I is 1. Just write it first wherever you want to see. 3 times 2 plus. When I is 2. Plus. When I is 3. Plus. When I is 4. And plus. So this is 6, and this is 12, and this is 20, and this is 30, and this is 42. So this is 50, this is 54, so 104, 110. This is the end of the new material in this class. We have time to practice, and you tell me what you would like to go back to for test 3. Anything. I gave out a little review. If you want to start with that, we can start with that. If you, that's fine. I don't think I have another copy. Nope, I don't. So I'll wait. I'll rely on you to say, let's do this or let's do that. Would you like to start with a system? There must be a system there with Gauss-Jordan. Would you like to start with a system? Would you like to start with a system or some other problem? It doesn't matter.
System.
Yes. Any problem?
X plus Y
Yes?
equals parentheses, the next one, parentheses X minus 3 squared plus Y plus 6 squared equals 34.
Very good. So this is a system of two what? It's equations, but what type?
One's linear, one's nonlinear.
Very good. So it's considered a nonlinear system of equations. Excellent. Very good. So then my only chance, since these variables are not the same, my only chance must be substitution. That's my only chance. So it doesn't matter what you want to substitute for. So x equals negative y minus 11. I will replace this in the second equation. So please dictate the second equation. Very good. Perfect. So yes, it is negative y minus 14 everything squared plus y plus 6 everything squared equals 34. Perfect. Please make me proud and tell me how many terms will you give for this and how many terms will you give for this, please. On the first day of classes, the first handout. Oh, we encounter this every class. There was not, I don't think there was one in which I didn't ask you to square binomial. Okay, so let's see what we have.
3y squared plus
What is 14 times 14?
197
Thank you. Plus,
y squared
very good,
12y plus 36.
minus 34 equals 0. Say it again. Oh, yeah, yes, thank you, thank you. Let's combine like terms. Y squared plus y squared, 2y squared, very good. And then we have plus 40y, and this is 198. And I know you know what I am going to do next. Absolutely. Thank you. So y squared plus 20y plus 99 equals 0. Now this is quadratic. So I have 4 methods. Remember 4 methods of solving quadratics. Taking square roots, completing the square, never, factoring, and a quadratic formula. Yes, if it takes too long, please use the quadratic formula. Don't waste your time. But remember 99 is 3 times 3 times 11. Yes, yes, indeed. So I'm sorry, y plus 11 and y plus 9. Very good, awesome. So then y equals negative 11 and y equals negative 9. Not good enough. It's very good, but not good enough. I have to go back to x. Here's x. X is negative y minus 11. So when I plug in negative 11 with minus in front, that will be positive 11. Minus 11 is good. Now I plug in negative 9 with minus in front. So 9 minus 11. So this system appears to have, I have no clue. I could have made so many errors, but it appears to have two solutions. 0, negative, very good. Very good. So please go back and check. Please, always. So you're making sure that you don't have an error, right? You don't want to lose points. Perfect. Next problem of any kind for test 3. Anything you want. Logs, exponentials, anything you want. Solving equations, anything you want. If you want me to pick something, I will. Yes. So what is it?
X minus 2 plus y. Exponential, the sign.
Okay. So e to x minus 2 plus 1. Awesome. Thank you.
I have a question. When
Yes.
you circle no, does that mean it's not going to be on the test?
This is what I did sometime few semesters ago.
Oh.
It doesn't mean that it's not going to be in the test. Yeah. If we solve the problem like that in class, it can be on the test. If we haven't solved a problem like that in class, it will not be on the test. So here's a function and we want to graph it using transformations. What is the base function here? E raised to x. Very good. First transformation on e to the x. So e to x minus 2. Right to, indeed.
There was another one that we did that you said it no longer did that. That made no sense, I'm sorry. There was one math problem that we worked on 2 classes ago, and it might have been 3 classes ago, and you said that it no longer means that the opposite when it's
It was a natural log with something like negative x plus 1. So because it was negative x inside a function, we had to flip it first and then move it the other way. But this is not a negative x. Very good point. This is not a negative x. Okay, so this is right too. And then, happy Thanksgiving. See you Tuesday. Okay, and then, very good, awesome. I'm sorry, you said it twice, forgive me. Okay. How do I graph e to the x? It's an exponential function. There are 2 options, either increasing on all its domain or decreasing on all its domain. Why is it increasing? Because the base is great, and there is no negative base. Because the base is greater than 1. And the exponential function e to the x must cross at 0, 1, like any pure exponential function. If it's decreasing or increasing, it doesn't matter. It has to cross at 1. Good. Then you told me to move this graph to the right. Please give me the marker. Where does the marker go? Very good. Awesome. And then you told me what? But I have to be careful because these 2 functions have a horizontal asymptote that is y equals 0. So if I push the graph up 1, what do I have to push first? Correct. Correct. Yes. Awesome. So here it is. Y equals 1. The original one had y equals 0.
So do we have to still graph
No, because it's the x-axis.
Okay.
So now please give me the marker and tell me where it's going. 2, 3 indeed. Awesome. So this is e to x minus 2 plus 1 indeed. And it has a horizontal asymptote of y equals 1. Any questions?